Okay, grade 12s. Okay, let's have a look at last year's parabola. Last year they gave us f to the x is equal to negative 2x squared. And they drew us the picture, okay, and it was a graph that was going down like that. We know it goes through the point 0, 0. I don't know if I substitute a point in, but if I substitute 2 in, I'm going to get negative 8, okay? Therefore, I do know that minus 2 and minus 8 is also going to lie on the function again. Then they happen to give me a hyperbola that is going something like that and something like that, okay? And they asked me to find the value in the hyperbola. They told me is g to the x is equal to k over x. And they told me that the coordinate e lies on that hyperbola. So minus 2 over 3 must equal k over negative 3. If I multiply through, I'm going to get k is equal to 2. I don't know what's wrong with my pen, folks. All right, so that I've done. Then the next thing, they want the coordinates of the point of intersection. So I'm going to let minus 2x squared equal 2 over x. Multiply through, I'll get negative 2x cubed equal to 2. I'll get x cubed equal to minus 1, and therefore x is minus 1. And if x is minus 1 and I substitute it into the hyperbola, I will get positive negative 2. So A's coordinates are negative, what's wrong with this pen? Negative 1 and negative 2. Okay. Write down the equation of the inverse of the parabola. So, in order to find the inverse of a parabola, I have y is equal to negative 2x squared. What do? I swap x's for y. I then want to make y the subject of the formula, and as soon as I take the square root, it becomes plus or minus negative x over 2 is equal to y. Why is this not a function? Okay, because if you think about it, if you had to swap these coordinates around, so it's going to come minus 8 and positive 2. Let me just change colors. 2 and minus 8 will become minus 8 and 2, and minus 8 and minus 2. The parabola is going to go something like that, okay? And if you had to draw a horizontal line down, you would get a one to many. Therefore, it is not a function, okay? What are the points of intersection between these two graphs? Well, they're obviously going to go through at 0, 0, okay? But now you don't want to go and make that function equal to that function. You're going to get lost. So you know that they always go over the y is equal to x line. So rather make minus 2x squared, y is equal to x equal to x. I'm sorry this thing's so bad. Negative 2x squared minus x is equal to 0. I'm going to take out negative x. I'm left with 2x plus 1. So I know that x is equal to 0, or x is equal to minus a half. And I know that at the point where they intersect, x will be equal to y. So the point of intersection is going to be negative a half and negative a half. Restrict the domain of the original so that the function is so that the inverse is a function. To restrict the domain of the original, I only want one arm of it. So in this case, x must either be smaller than or equal to 0, or x must be greater than or equal to 0. Basically, you want from the left-hand side of your turning point or the right-hand side of your turning point. And then they want to know what will h become if k is shifted, which is not mathematically right. It is whatever it's called, 2 units to the right and reflected over the y-axis. So what did we get? Oh, k value to be 2, hey? So g to the x is equal to 2 over x. So the first thing I do is if I want to translate it 2 units to the right, I add 2 units. I add 2 to the right. So I'm going to minus 2 units because I'm going to go in the opposite direction. And now if I want to reflect this over the y-axis, if I'm swapping something over the y-axis, all positive x's become negative. So this will become 2 over negative x minus 2.